Welcome to Lesson 35, Locating and Using Intercepts. Okay, we're going to be graphing today, obviously, if we're using intercepts. So we're going to be graphing linear equations today, which is review as an equation whose graph is a line. That's where the word linear comes from. But we are going to be looking at standard form today. So please write in what standard form is on your notes. Standard form is ax plus by equals c. My x doesn't look very good here. Okay, ax plus by equals c. And you should know what an x-intercept is already, but it happens to be the x-coordinate. We usually only give the x-coordinate when we're talking about x-intercepts. Of the point on the line where the graph intersects or crosses the x-axis. And then the y, similarly, is the y-coordinate of the point where the graph intersects or crosses the y-axis. Now I just want to point out here, this is very important and I'd like you to write it down, that the x-intercept is the point when y equals 0. So if it's crossing the x-axis, it's at the 0 point on the y-axis. And similarly for the y-intercept, it's the opposite. It's when x equals 0. Okay, so let's try a little bit of this here. Let me change my pen color back. Okay, find the x and y intercepts for this equation. 2x plus 5y equals 10. So, as we already pointed out, for the x-intercept we want y to be 0. And for the y-intercept we want x to be 0. So we're just going to solve the equation using these two coordinates. So the first thing is, we're using this equation, and we're going to fill in 0 for y. So we'll still have 2x plus 5 times 0 equals 10. Now we know that 5 times 0 is going to be 0, and adding 0 or subtracting 0, which would be the inverse from 10, would still be 10. So we're going to have 2x equals 10. And then we divide by 2, and x would be 5. So that's the x-intercept. And for the y-intercept, we'll use the same equation, but we'll fill in 0 for x this time. And then we'd have 5y equals 10. And we know that 2 times 0 is going to be 0. And 0 plus 5y isn't going to change 5y, so it's still going to be 5y equals 10. We divide by 5 on each side, and we have y equals 2. So this is our x-intercept, and this is our y-intercept. The next example, we're going to graph these points using the x and y-intercept. So we're going to do the same thing we just did using this new equation. So we're going to fill in 0 for y and 0 for x and solve. So the first one here, and I have to write small, is going to be 3x minus 7 times 0 equals 21. And this is going to end up being 0. 3x minus 0 is still 3x. So we'd have 3x equals 21. Divide by 3. And we have x equals 7. So that's going to be one of our points is 7, 0. Okay, and I'll do this on the other side, or down below here. We're going to have 3 times 0 this time. minus 7y equals 21. Now this is a little different because we know that 3 times 0 is going to be 0. But by getting rid of that, we still have a negative, or subtract 7y, which is a negative. So we have negative 7y equals 21. If we divide by negative 7 on both sides, we'll have y equals negative 3. So that's important for our point. So if we're going to graph it, over here in our graph, I actually made this, the graph I copied in here is a little too small. So we'll just add another box here. So our first point for the crossing the x-axis is 7, 0. So we go over 7 and we don't go up or down any. Just put our point there right on the x-axis. And then the y-intercept is negative 3. So we go down to negative 3 and put our point there. And my stylus doesn't seem to want to work here. There we go. And then we can just connect them. And draw our line. And there we have it. The next example, we're just going to find the x and y intercepts on the graphs. They're already graphed for us. So to find the x-intercept, we're going to look at the x-axis going left and right and find where it crosses, which is right here. And for the y, we look up and down to find where it crosses, which is right there. So the x-intercept is x equals negative 1, 2, 3. And the y-intercept is y equals positive 1. And then over here we have the x is it's crossing the x-axis right here, so x equals positive 3 this time. And it's crossing the y-axis up here, which is y equals 6. So pretty simple when you already have the graph in front of you. On the next example, it says to write the equation in standard form and then graph it. Now right now the equation is in slope-intercept form, which is also an easy form to graph from. But today we're practicing standard form, so we're going to have to rearrange some things so that we can do that. So we'll rewrite the equation down below here. Now in standard form, the constant, which in this equation is 4, is all by itself on one side of the equal sign, and the x and the y are both together on the other side. So we want to move this x over to be with the y. So we would add 1/2 x on both sides. So we would have 1/2 x plus y equals 4. And that would be our standard form. So now to find the x and the y intercepts, we could make ourselves a table and fill in 0 for each x and y. So for x, if we fill in 0 for x, we can see that this is going to become 0, and then we're just left with y equals 4. So that's nice and easy. So the next example, or the next one to solve for here is 1/2 x plus 0 equals 4. And that's just going to cancel. So we'd have 1/2 x equals 4. So we'd multiply by 2 over 1 on both sides. And we would have x equals 8. So then we just have to plot those points. So y, the y-intercept is 4, so we'd go up to positive 4 here and put our point. And the other one is, again, off of the axis. I'm sorry that I didn't check that before I put these on here. I just put them on. So our x-intercept is over here at positive 8. And then we would just connect our points and we have our line. Okay, the last example is an application problem for the real world. So it says at a football game, student tickets are $3 and adult tickets are $5. Let X be the number for student tickets and let Y be the number for adult tickets. So let's make those different colors so we don't get confused here. So X is student and Y is adult. And they give us an equation, 3x plus 5 equals 630. And that shows the amount of money raised from the ticket sales. So we have to find the intercepts and then explain what they mean. So we'll start by finding the intercepts. If we fill in 3x plus 5 times 0 equals 630, the 0 is going to make that 5 a 0. So we'll have 3x equals 630, and then divide by 3 on each side, and we have x equals 210. So this is 210, and x is representing the number of tickets sold that were student tickets. So that means there are 210 student tickets sold, and this represents that there were only student tickets sold. So when 0 adult tickets are sold. Which means that only students attend the game in this scenario. And then if we find the y-intercept, we would fill in 0 for x. And that's going to cancel out to be 0. And then we'd have 5y equals 630. Divide by 5. And we have y equals 126. So that's 126 adult tickets with 0 student tickets. So that means only adults attend the game in this scenario. And that's what we did. We answered this part of the question. Explain what each means. So we explained that the x-intercept represents a game where only students attend and buy tickets, and the y-intercept represents a game in which only adults buy tickets and attend the game. And that is our lesson for today. Thank you for listening and taking notes.